Hello everyone, I am grateful that you are watching my video lecture, and today's topic is oxidation reduction titration iodometry. So, above all, I would like to start with the definition of oxidation reduction titration. This type of titration is based on the oxidation reduction reaction. So it is a reaction which is based on the chemical interaction between oxidant and reducer. The titrant can be either oxidant or reducer. This type of titration is classified into oxidometry and reductometry. Oxidometry, for example, it is permanganometry, titration, and so on. So, unlike reductometry, the titrant in the case of oxidometry is oxidant, whereas in the reductometry, the titrant is ascorbic acid. So, what we need to know about this classification, that in the case of oxidometry, the titrant is the oxidant. In the case of reductometry, the titrant is reducer. For instance, it can be the method which is called ascorbometry. Okay, so what about the iodometry? Yes, well, iodometry is quite widespread chemical methods of analysis which is used in the laboratories. So this method, the titrant of this method is pre-iodine solution, and sodium thiosulfate. Yes, in this method we have two titrants, and it is pay attention to that. So let's discuss this method in more details. As I said before, we have two titrants, iodine solution and sodium thiosulfate. Sodium thiosulfate, this type of titrant is used when we need to find out the concentration of oxidant. Whereas in the case of reducer, we are going to use iodine solution. What about the possibilities? Which substances we can identify, which can be quantified by this method? Well, first of all, we can identify oxidants such as potassium dichromate, potassium permanganate, and so on. In the case of reducers, we can easily quantify, for instance, ascorbic acid, different reducer agents as iron 2, tin 2, and so on. Also, we can find out the concentration of organic compounds such as phenol or, for instance, salicylic acid, and so on. Okay, so what about the indicator? Yes, you can ask me. In this case, we can use either starch as indicator, or we can use diphenylamine. Diphenylamine, it is a redox indicator, which is widely used in the different methods. In the case of starch is a specific indicator exactly for the iodometric method. When we need to add the starch, at which type of titration, and so on. In the case when we need to find out the concentration of reducers, we need to add starch at the beginning of titration, and we will see at the end point of titration the appearance of a blue color of solution. Whereas in the case of when we need to find out the concentration of oxidants, we need to add indicator at the end of titration. So, and we're gonna to see that there is disappearance of a dark blue color. So it is the main things which you need to memorize. Okay, so thank you so much for listening to me. You will get more information in the distance in our in the distant course of our department. Thank you and have a nice day. Bye bye.